Greetings from wherever you are joining us. I'm Helen Teplitskaya, founder and president of Global Alliance on Sustainability and AI, GASAI. Today, three people at the forefront of this for years are with us. Please welcome Steve Suarez, founder and CEO of Horizon X, senior advisor to McKinsey, and co-founder of the Quantum Index. Dr. Alessandro Curioni, IBM Fellow, Vice President, Europe and Africa, and Global Research Vice President for Algorithms and Applications at IBM Research, and Yuval Boger, Chief Commercial Officer at QR Computing, my fellow Kellogg alum. Over to my co-host, dear friend, GASAI Director of Technical Education, the ethical AI guy, Tom Testi. Tom, the floor is yours.
Thank you, Helen. As senior advisor at McKinsey, you helped sponsor the Quantum Technology Monitor, one of the most closely followed reports in the quantum industry. What are some of the key findings that stand out to you for people who have not really had the chance to read the full report?
Yeah, thank you, Tom, and thank you guys for having me. I'm actually in the UAE right now, so I really appreciate the comments, Helen, around what the government here is doing. One of the key things I wanted to add to what you were saying is they're also offering open AI to everybody in the country for free. So they're going through making that and really pushing what they believe in is to make the citizens more AI aware. And I find that to be very interesting. Tom, going back to your question, obviously the report's 102 pages long, a lot of information in there. But let me tell you kind of the key facts that I find interesting, and I hope your readers or the people listening will find interesting. Number one is if you think about the opportunity. Now, I'm not talking about the quantum companies. I know we've got Yuval on here from Quantum Computing, and there's a lot of valuations on quantum computing companies that are going through the roof, which is actually really exciting in the industry. From my perspective, I look at the commercial players and where they're going. And one of the things that we came up in the report is the potential value of where they can be more useful to me. And then the last one, which that was called quantum vigilance or quantum signals. And the last one is quantum resilience, which is how am I going to protect the company based on the cryptography and everything I need to put in place. So one is, what are the opportunities? One is, what is the outside market doing and what should I be paying attention to? And the last one is, what is the resilience that I need to be focused on to make sure that my organization is protected from the upcoming quantum computing?
As always, excellent. I wonder if the audience has any questions or we will handle them a little later.
Well, I was having some problems I put the link for the report into the chat, but apparently some people are getting access denied. So I would recommend that they just Google Quantum Technology Monitor, because I was able to get to it. So
I did that, and the first thing that pops up gives you the same link, and you get the same error.
Okay.
Yeah, you have to register for it. So it's I think you're probably already signed in. So if you could, I'll send out the link.
Okay.
Where you can get access to it, and then you have to register to be able to go in. So that's why the ones who have access are the ones that registered, but the others can just go in here and register an account.
I wonder if we have Alessandro Curioni with us. Alessandro,
yes,
are you with us?
He's here.
Oh, this is fantastic. I was a little nervous. Today is a day of interesting technicalities. So, Alessandro, thank you so much for joining us from your vacation. We're thrilled to have you. And I will turn the floor to Tom to ask you the first question.
Hi, Alessandro.
Thank you for the invitation. Hi. Good afternoon, good evening, good morning, whatever it is.
Yeah, Alessandro is the Vice President of Europe and Africa Director, IBM Research in Europe at Zurich, Switzerland. He's an IBM Fellow and a Global Research Vice President for Algorithms and Applications. So welcome, Alessandro. How do you see the synergies between AI and quantum computing transforming business and society?
Thank you. Thank you very much for the invitation and allowing me to share my vision, our vision about quantum and the interaction with AI. Look, I do believe that first, we are simply scratching the surface of what this technology can bring to business and society. Yeah, you call your meeting series now Quantum plus AI. I am telling everybody that it's going to be quantums times AI. Why? Because probably we are not fully understanding the impact that these technologies are going to have and the synergies between these two technologies. It's not only a question of what you can do or what you can solve with AI and quantum. AI, for the first time, gave us an instrument to create new abstraction or reality of problems that we want to solve, right? So you don't go anymore from the problem translation on a mathematical abstraction. You take this one, you try to solve on a computer, you discretize, you put on a computer, and then you have an outcome. But you can go directly from observation, data, a surrogate model, and afterwards, an outcome. Same time, quantum, for the first time, is again, is not only something that is going to accelerate application ABC, but is redefining the way we represent information. Yeah, so we create a new abstraction with AI, which is represent information in a different way with quantum. So think about inventing, and that is what we are putting a lot of effort in IBM research, inventing a new algorithmic layer that take advantage of the possibility to have new abstraction run on top of new representation. The synergy is much, much, much larger than simply having quantum for AI or AI and quantum, right? We are only at the beginning, but a lot of work that is going on exactly to revisited and reinventing this algorithmic layer that is going to allow us to do many of the things that we were doing in the past much more effectively, and many new things that we could not do in the past. Yeah, so this to start. Second, if you do one step back and you say, okay, that is a journey, that is your vision, right? But need a lot of work and research to get there. What you can do today, AI and the new AI is already helping quantum and quantum development in a very, very, very strong way. And is doing it at all the layer, right, of the, let's say, quantum ecosystem. AI can help, is already helping now to design faster and better new ASIC to do decoding, right? And error correction. In the past, you needed months to do this. Today, we can test new ideas and design in weeks. Yeah, so impact to the hardware. Is already impacting at the middleware. Once you have a quantum computer with an architecture and a connectivity, then you have to map, circuits and gates on top of this, and how to do this in a most efficient way for a given architecture. AI can help and is helping enormously. Also, is helping enormously one level up at the algorithmic layer. We do have many quantum algorithms primitives that we do know that at the circuit level, they do have an advantage over classical. The problem that we do have is that how to connect this to real application. Yes?
Right.
So AI can help to do this. So it's already helping, by the way. Recently, we discovered a couple of algorithms exactly doing these AI-driven things. Not discovered algorithms. The algorithms were already existing, but we connected algorithms to possible application using these methodologies. And the last things, it helps also at the application layer. Once you do have a problem, for example, a complex optimization problems, we do know already that the best way to tackle these problems is not only with quantum alone or with classical alone, but is trying to bring these things together. Okay, so how you split your algorithms in a classical plus quantum in the most effective way. Again, AI is helping to do this. So you see, aside the longer term vision that is very transformational, you do have a short term where it is already evident and impactful the usage of AI for quantum.
Okay. Helen?
Well, as I mentioned in the beginning, most of us still think, well, quantum is somewhere in the distant future. So how is quantum computing creating value in business today? And which industries are benefiting the most?
Yes.
Is,
Again,
is it
another
already
very
real? Because some people
yes.
imagine it's still far away.
Yes, there are many people that think that is still far away, and there are people that simply because today they are not able to connect what we do have, right, to value. They are saying we have to wait another 5 years to have error correcting machine to create a real value. Yeah, but that is an excuse because two reasons. One, we don't have in technology and in science, never have, a situation in which you go from not having something to have something that is perfect. Yeah? It's never like that. You always go through a incremental journey in which you make the technology better. And also with error correction, it's not going to come all by once. You start to correct a part of the circuit, a part of the gates, the memory, and more of these you are able to do, right? A larger amount of cycle you will be able, or gate operation you will be able to do, right? And so more value or problem you will be able to solve. And this, if you go back, let's say 10 years, when we as IBM, we put the first 5 qubits on the cloud, you could not do almost anything. One did operation and you had the occurrence. Today, you can do 5,000 on the 100 qubits. Next year, right, we are going to double this. In 2029, we will be able to do 100 million. What does it mean? It means that if you are able to start, you were able to start in the past and start to develop the right algorithm, you can increase the value that you are creating almost day by day. And it's going to be in a continuous way. That is a very important thing. A continuous that is not going to be linear. Maybe it's going to be, exponential in impact because when you get to a certain size of qubits and operation that you can do, the value that you create is much larger. And but you can start to create value now. Example, if you go back only 2 years, when we started to use quantum for Hamiltonian simulation, namely use quantum computing to simulate atom molecules materials, okay? We could simulate a couple of years ago 2 free atoms, molecules with 2 free atoms. We went then to 10 atoms in 2 years, to 40, to 50, to 100. This year, for the first time with the Cleveland Clinic, we were able to show that we could simulate system with 14,000 atoms. Okay, this in 2 years. Simulating larger system is not the full story, but simulating larger systems with the right sampling of the space brings you to the ability to start to do better drug design. Yes? And you can say it is still away, but from 3 atoms to 14,000 in 2 years. Yes, and we are able to do this with a budget of 5,000 gate operation before decoherence. Think about what is going to happen with the same strategy, only 3 years from now when we are going to have 100 million gate operation. Okay? I don't know if you have followed, but another demonstration that was not done by us, but was done by our partners using our technology. Welcome Leap had started a challenge a couple of years ago, exactly to push the community to try to find and demonstrate quantum utility and advantage for drug discovery. Okay? Everybody could participate. Some of our partners participated together with us, for example, Algorithmic plus Cleveland Clinic, and they won this year the $2 million prize that was a prize for early utility. What they were able to do, were able to simulate a chromophore, so a piece of a molecule, okay, that is can be embedded in a chemotherapy, so that if you excite this chromophore with light, right, the chemotherapy becomes active only when it is excited. That you can say it is an early thing and is not still at scale, but is already initial value. Okay? Go away from molecular simulation, look more at and that is a very interesting example, on the finance world. A few months ago, HSBC came out with a paper where they demonstrated that trying to integrate quantum in their workflow to do algorithmic trading was allowing them to calculate the probability that a given stock investment would fill for a given price 30%, 34% better than what they had before. Again, the very interesting thing here is that it's difficult from a theoretical viewpoint to understand what was really the impact of quantum to get this 34% more. But simply the fact that they started to re-engineering their algorithm to include quantum created value. This demonstrated that can bring value in a direct way, but also in an indirect way, because push industry to rethink and engineering their algorithm and the way they are doing things. And these are only 2 examples, but you can enlarge and for us, going back to what I was telling you before, we decided to stop to simply doing research for particular vertical use cases. Why? Because we do think that people were already demonstrated that, in certain things that everybody say, drug design, materials, optimization, quantum machine learning, you could do things. We have done a step back and simply saying, let's try to focus the research on algorithmic classes, because we do believe that the interaction between AI and quantum is going to be super important and synergistic. And there are 4 classes of algorithms we are focusing. One is Hamiltonian simulation, so all the problems that can connect it, to solve an Hamiltonian system in an Hilbert space, molecule, atom, drugs, etc., etc. Second class is partial differential equation. Most of the engineering world is based on solving differential equation, for example, fluid dynamics, computational fluid dynamics. Do one step back, how we can bring together AI surrogate model plus quantum to create a library to make CFD and all differential equation much more effective. Third class is global optimization. And when we say global optimization, is multi-objective global optimization problems. Yeah, again, same philosophy. And the fourth class that probably is the one that is a little bit more premature, but I do believe that in the long term is going to bring more value. It's quantum machine learning. Yeah, everybody speaking about quantum machine learning. There are not many proof of value yet, but from I would say intuition viewpoint, something should happen there. And why I'm saying this, think about what you are doing with the Shor algorithms. It's exactly trying to find a hidden structure of a number. You have a number that is the multiplication of two other numbers, right? And with quantum computing, you are able to extract these two numbers that are not visible before. So try to extrapolate this. Take another data set, maybe a small graph, that if you look at it, you don't see the hidden structure that is inside, but eventually with quantum, in the same way, you could do it. And you know the number of problems that you could solve if you are able to tackle that is enormously. Okay?
Yeah. Well, speaking of that, what impact will quantum computing have on cybersecurity, and how can organizations mitigate these risks?
I think that the previous speaker already mentioned about this. One thing that everybody says and knows since day one, because Shor algorithm was the first clean, theoretically proved algorithm where you can have, an exponential speed up. We will be able to break all the important keys in cryptography, RSA, but also elliptic cryptography. In the past, people were focusing only on RSA and say, elliptic cryptography is going to be a little bit more difficult to break. Recently, we discovered it is the other way around. What does it mean? It means that everything, the internet, authentication, digital signature, code signature, but also all the cryptocurrency and digital currency that has been developed so far are going to be in danger. Yes? And the very interesting things, take away the executive order that are welcome, right? We are saying this since 5-6 years, is not only is also wrong to think that you are going to have only a coup day, as I told you before, a day before and a day after, where from a day everything is safe, the day after everything is unsafe. It's not going to be like this. There are things that are unsafe already today. A cyber criminal can harvest your encrypted data, put it aside, wait to have a quantum computer, and decrypt 10 years later. So super sensitive data are in danger already today. So what you can do is to take this data, decrypt, re-encrypt, store the key in the right way so that you are safe. Yes?
Yeah.
And but step by step, different institutions at different times they will need and still need, they will need to do it already starting from today to move everything to quantum safe encryption. We do have the algorithms. NIST has done standardization of these algorithms. Okay, it's time to move forward and to migrate. Interesting things is that this is not going to be like year 2000 problem, as I told you. We will have a serious different days in times because first time somebody is going to have a quantum computer is not going to attack my or your bank account, right? It's going to try to attack the national security type of problem. So at the beginning, governments are going to be the point of attack. Then you will have more resources. You do one step after. So what I'm trying to say is that everybody, every organization, every government should look at their own risk and start to migrate with urgency now. And it's not going to be only a single migration, but probably it's going to be a series of migration. Why? Because one, you cannot be sure 100% that the new standards that have been created are going to be safe forever. Yeah, that is one reason. But the other reason is that these standards are very, very good, very, very strong in terms of security, but they have limitation. For example, if you want to use it for digital currency or in cryptocurrency, the latency of the standards that we do have now is too high. So the community is developing new algorithms every day to try to reduce latency. So you can expect to have a series of cryptographic changes that are needed. And that is why we do say company, businesses, institution needs to create a crypto agility type of approach to cybersecurity.
Yeah.
Will you join us for some of our next events to elaborate on this crypto agility? Because really, from my own interactions with multiple peers across industries, basically nobody is really quantum ready. There is no quantum ready workforce, at large, and this is a huge problem.
Is a huge problem. Let me add one thing. What you say is true, but not 100% true, because there is a big difference between organizations that they have done it and they don't say, and organizations they didn't do it and they are not thinking to do it. So in other words, there are organizations that got already quantum safe in a silent mode. Because there are benefits, right, to do it without having everybody knowing. Yes.
What kind of a percentage would you allocate to this segment, or to this cohort, statistically speaking? Businesses, what kind of percentage?
I would say today 2-3%. 2-3, very small. Yes. And the ones that have moved faster for the moment are, of course, government and institution. Yes.
I was primarily alluding to businesses. And
Yes.
At least to me, it is scary that this percentage is minuscule. So I very much hope that you will join us again to elaborate a little bit on this cyber agility. But for now, what are the biggest challenges that quantum computing can help solve over the next decade? We addressed the issue of what is happening now, but how about the next decade? What do you think are the biggest challenges that quantum computing can help solve? And of course, amplified with maybe AI capabilities together.
Yes. I do strongly believe that exactly this amplification is what is going to make a huge difference. To me, the acceleration of the scientific methods at large is going to be the most important thing. Why? Because you are not accelerating one application, you are accelerating a method. And if you are accelerating this method and you make it more reliable, the amount of discovery that you can do from, trying to find better materials for batteries to try to being able to do fluid dynamic scale to design better vehicles, to analyze better data to understand what is happening, at our planet, right? To finally, the last step that is impact to healthcare, that at the moment it's limited exactly by the fact that creation of real digital twins of biological systems has been hampered by complexity and inaccuracy. So imagine if we are able to take away these problems, complexity, and have a better accuracy. We will be able really to create a digital twin in the healthcare space that will allow eventually to understand how we work better and eventually fight disease really. Yes, not only with words. Yes.
Well, thank you so very much. There are so many more questions. I hope you will be able to stay with us for a little while, maybe to address some questions from the audience. What's your schedule like? I know you're on vacation, Alessandro.
I can stay a little bit more if there are questions
Yes,
after. No problem.
I'm pretty sure that some members of our audience will be thrilled to ask you a question.
Good.
Tom?
Okay, I'd like to bring in Yuval Boger. He's the Chief Commercial Officer at QERA Computing, bringing natural atom quantum computing to the market. He's also the podcast host of the Superposition Guide. He's a speaker and author. Welcome, Yuval.
Thank you, Tom and Helen. Thanks for having me.
Okay, what does deployment agility actually mean for quantum right now? And how does a company build it before the hardware is fully mature?
Well, first, the hardware is maturing at an amazing pace. Just a couple of weeks ago, we announced together with Amazon that we will be deploying the first fault-tolerant quantum computing on the Amazon cloud. Fault-tolerant quantum computers are computers that can perform long calculations because they're able to detect and correct errors in individual qubits, something that has limited the usability of quantum computers until now. We see two modes of deployment, and of course, some combination of both. One is deployment on the cloud. Our first system with 256 qubits has been deployed on the Amazon cloud since November of 2022. So it's getting close to its 4th birthday. It's available for use 130 hours a week for worldwide users. If you have a credit card or an Amazon account, you can use it today. Cloud usage, of course, is advantageous because there's practically no setup required. You have the flexibility of trying out different computers. You can try our 256 qubit computer. You can try someone else's 26 qubit computer, but you can see which one is best for you. Of course, and then the second mode of deployment is on premises. Last year, we delivered a gate-based computer to our customer in Japan. That's AIST, the Japanese National Institute of Standards. That computer is co-located with a very strong classical supercomputer. And organizations can choose between cloud or on-prem or a combination of both. With cloud, there's, again, low upfront costs. There's flexibility in usage. But then when you own the computer, you certainly can guarantee that sensitive data does not leave your organization. So whether you're a pharma company or a government contractor, sometimes you say, I just need the data to remain behind the firewall. It is easier to create high-speed connectivity between classical and quantum computers in case you want to run hybrid algorithms. And of course, when you own the computer, you also own and control the priorities. You get to decide who runs first and who runs second. When we some time ago, BMW ran a 50-hour job on our quantum computer on Amazon. So if you that day wanted to submit your own job, you would have to wait 50 hours until your job was executed. And of course, if you own the computer, you could do whatever you want, whenever you wanted it.
Okay, Helen?
I muted myself. It's always tempting to throw in additional questions, but we're limited in time. So, Yuval, where's the quantum and AI convergence already producing value versus where it is still just a slide?
Well, there's certainly AI for quantum and quantum for AI. We see that an increasing number of programs for quantum computers are written by AI agents. So when one creates a programming language or creates documentation, it is important to see that they are visible and comprehensible to the AI agents that can sometimes do a faster and better job than humans. AI is certainly helping in the design of algorithms. We spoke a little bit about error correction. As others have mentioned, qubits are fragile. Regardless of how you make them, they can be impacted by environmental changes or other things. And so there's always a need to measure and correct errors, detect and correct errors, so you can perform long calculations. That process of measuring and detecting and correcting errors requires what's called a decoder, and decoders can be written using AI to be very efficient. So these are basically algorithms that read the status of a couple of qubits and then based on that make decisions. We certainly also are starting to see talk about quantum for AI. When you look at AI systems, say in chemistry, you could log into such a system and say, I'm looking for a compound that's blue, that's liquid in room temperature, that doesn't mix well with oil or whatever it is that you need. And the AI system will direct you at a class of compounds. Well, how does the AI system know that? It has been trained on experimental results from the past 200 or 250 years. Now, if there was a quantum computer that could simulate the behavior of compounds that have not been tested in the lab, then you could broaden the training base of these AI systems and contribute to their success. So that's sort of the other direction, how quantum can help and impact AI.
Pretty amazing.
Okay. How should a buyer think about modality choices when road mapping all promise fault tolerance?
Very carefully. I think there are certainly multiple ways to build quantum computers. We had a guest from IBM. They use superconducting qubits. We use what's called neutral atoms, individual natural atoms to use qubits. There are approaches in silicon. There are approaches with photons, particles of light. And I think we're now at the point where one can look at a couple of things. First, at Quora, one of our mottos is more science, less fiction. So we basically say we develop pretty much in the open. We publish our results in peer-reviewed journals, whether it's Nature or Science or PRX. And so when we say we're going to have a error-corrected computer in 2028 that's going to have 256 logical, meaning error-corrected qubits, and over 10,000 physical qubits, that's not just hand-waving. That's backed by science, and we've shown critical components to scaling to large number of qubits, to do real-time error correction, to do continuous operation, to overcome some of the issues that happen in neutral atoms. So we think that first you should have sort of a inquisitive eye to say, your brochure looks great, but show me that you've actually done something. If you haven't shown a single error-corrected qubit today, it's perhaps unlikely that next year you'll have 10,000 error-corrected qubits, right? You don't go from 0 to 100 in 0.2 seconds usually. The second thing is when you can look at the individual capabilities and inherent advantages and disadvantages of every modality. So for instance, when you look at superconducting qubits, one of the nice things about superconducting qubits is that operations are very, very fast, meaning that if you could build a computer that was good enough, it can perform many calculations in a short amount of time. However, that approach of superconducting qubits has certain disadvantages that are, as you would expect, advantages of other modalities. The first thing is the deployment. When you think about a superconducting qubit, if you Google quantum computers, you're likely to see this golden chandelier that's part of the cryogenic cooling system that makes sure that qubits get to near absolute zero temperature. these systems are incredibly expensive and incredibly power hungry. So when you look at some of the computers that are built, say, in the Chicago area, you see that they can take the size of a football field and maybe require 100 megawatts of power to operate. When you look at a computer like Suarez, that's actually more advanced, you're looking at a room size. Our CTO says it can fit in his garage, and in tens of kilowatts of power, not megawatts of power. The other thing is scalability. You can start saying, okay, one needs a lot of qubits. How do you get to a lot of qubits? When you manufacture qubits, such as a superconducting chip, there are yield issues. There's a concern about how many qubits you can put on a single chip. And if you need tens of thousands or hundreds of thousands of qubits, that requires many, many chips, and then you have to interconnect them, and then everything gets more complex and slow and expensive. We and others have shown in neutral atoms that we can put thousands or soon tens of thousands of qubits on a single computer. So our deployment is also simpler. Another thing that you see in neutral atoms, the qubits can move. We can make them move, meaning that we can take two qubits that are far apart, we can bring them together. When they're together, we can make them act on each other. We can make them entangle. On a superconducting qubit, the connectivity is fixed. Why is that important? It's important because you remember when we were kids, you used to play the game of telephone. You'd have 20 kids sitting in a row, and your job was to get the message from the first kid to the last kid, but you can only speak to the person next to you. And of course, by the time it got to the other side of the column, the message was completely garbled. This is actually what happens in superconducting qubits. Every qubit can only communicate with nearby qubits. So if you have to make many sort of these transfer operations, that takes time and increases the error. In neutral atoms, one can just bring the first and last qubits together and operate on them. Neutral atoms also have disadvantages. So no technology is perfect, but I think you can look at the published data and you ask yourself, how many error-corrected qubits you have, how good are they, and sort of evaluate the credibility of that company's roadmap.
Helen, you're on mute.
I'm pretty sure most of our audience, the head is spinning. These are complex matters, but few of us really understand that we really have to kind of dig into this one way or another. We have to understand. I came across banking industry peers who actually were able to meaningfully discuss quantum readiness. I have not met a single insurance company executive who would hint about quantum readiness, and they possess so much of our data. It's scary to think that, we might not be protected if the insurance industry, for example, is not quantum ready by the deadline. But kind of setting into a more practical mode, saying looking 12 to 36 months out, what separates the organizations that thrive from those that fall behind from a practical standpoint?
Well, when we announced together with Amazon that Amazon will have the first error-corrected fault-tolerant quantum computer in 2028, one question that analysts ask is, why announce now? Amazon is actually known for announcing things when they're ready, not pre-announcing. And so one of the questions that came to Eric Kessler, the general manager of Amazon Quantum, is, why are you talking to us now about something that you will deploy in 2028? And the reason is that organizations need to get ready. Organizations need to understand that quantum is no longer a one-day thing and is getting closer and closer to being a day one thing. So as you move from one day to day one, you have to start understanding which problems in your organization are worth solving with a quantum computer, which problems are feasible to solve with a quantum computer, Do today and the upcoming quantum computers, are they sufficiently strong, sufficiently large to solve these problems? So meaning, are you able to solve just toy problems or real problems? So there's problem selection. After that, programming a quantum computer is different than programming a classical computer today. So you have to do work to encode, to choose the algorithm and encode the specific problem in a way that's suitable to the quantum computer. You then want to simulate on a digital twin, because access to a quantum computer may be expensive, or maybe the computer is not ready yet, but the simulator is ready. So this process could take 12 months or 18 months. So if you say Amazon will have a Quera quantum computer on the cloud in 2028, and you work 18 months backward, you say, this is the time to start understanding. The best time was yesterday, but if you hadn't started yesterday, you should really start today, because imagine what would happen if the computer is there and your biggest competitor is gaining competitive advantage by running a quantum algorithm while you are still thinking how to spell quantum. It takes time to catch up. It takes time to learn and to model and to simulate. And so the time to start is now. And that's why Amazon announced a 28 availability, even though we're just in 2026 today.
Well, this sounds very promising.
We have a question in the chat if we want to
Well,
go.
let's go to the open mic, because we promised we have some people who signed up ahead of the
Okay.
questions. And then we will open the floor. We have 4 people who signed ahead and, to reserve their open mic slot. And the first is Joe Reddix. Joe, are you with us?
Okay, first of all, this is an excellent conversation. One of the things that I would say about quantum and AI is that portions of the strategy have been around for a long time. Quantum computers, whether MRI or whatever, and AI as far as co-piloting and all that. One of the major issues, and I'm right next to the NSA and Fort Meade here in Maryland, is workforce development. So we started a K-12 program over at the Fort so that they can understand not just the jargon, but the integration of these kinds of systems. Now, quantum is important, and initially I looked at it from optimization of algorithms and things like that, because there's a clear classical quantum bridge requirement that has to be met. Classical computers are not going anywhere, nor should they. But the beauty in this is that the strategic value has dual purpose, both commercial and defense. In other words, you can have Skynet and you can have BINET, and you combine both and use quantum and AI, you can optimize the requirements of both. So it's a major use case strategy, okay? Now, given all of that, there are questions related to both environments, classical and quantum, how they're going to ultimately end up, nobody knows. But they have a key issue that I think could be a make and break, and that clearly is the issue of cybersecurity, okay? Perfect example, I'm a member of the Quantum Security Alliance. The founder of the QSA is the current Chief Information Security Officer, J. Aaron Bishop of the Department of War. So I communicate a lot at that level, and trust me, even before we get to the aspects of time, weapon systems and things like that, quantum and AI, if you can't solve holistically and in a great fashion, can ruin all the best laid plans, okay? So what does that bring to the table? Now we're talking about policy, okay? Policy and workforce development, those are areas that can take the best things that we talk about in these conversations and just basically ruin them all, okay? So that's kind of like what I've been looking at. Now, given that this is both a domestic and international capability and a requirement, bridging that kind of issue, and it's a little bit harder nowadays, but with organizations like QSA and QSecDef and stuff like that, it seems that it's capable of bridging, because there's no way in the world one entity or one corporation is going to have ownership of quantum or AI or whatever. So those are my major issues. these are things that if they're not resolved, billions of dollars in a multi-trillion-dollar initiative, which is what quantum and AI is. And Helen and Tom, you know the value when you start talking about money, people start paying attention. I'm not going to talk about Elon Musk or whatever. We already know where that's going, but that has to have something that coordinates that, okay, and brings some sensibility. In other words, one size does not fit all, okay? So I'm going to stop with that, but these kinds of conversations and the kind of consulting that comes from them that people like us bring to the table, I think is one of the major enablers that will help make this whole environment something worthwhile working with. Thanks, okay?
Thank you, Joe. Thank you so much. Joe and I are now working together on our new quantum AI advisory initiative. So if you would like your boards and, just senior executive team to be briefed on the issue, we'd be delighted to assist you. 𝐻umayun, are you with us?
Yeah, good afternoon, good evening.
As I always try to be fair, we open the floor to the world's leading quantum and AI experts, and we also open the floor to our young IT professionals who are curious and who will build our future. 𝐻umayun, the floor is yours, up to 3 minutes. 𝐻umayun, you are from Uzbekistan.
Yes,
right?
Thank you. This has been a great discussion. My name is 𝐻umayun, and I work on the applied side. I build AI native products quickly, and I often prototyping and refining ideas for real business teams. And one thing that stands out from me about your point is organizational quantum strategy. Is that it echoes something I can constantly see in AI adoption. And leaders often wait for a technology to feel fully mature before committing a strategy. And but by the time it feels mature, early movers already have a real head start. So my question in this, for an organization that genuinely resource constrained and it can be run on dedicated quantum research team, what does a lightweight but meaningful quantum strategy actually look like? And is it a small pilot experiment or building internal literacy so the organization can act quickly later, or something else entirely?
Volunteers to answer this question. Alessandro, Steve, are you still with us?
Yes.
If the organization is small,
Yes.
what are they supposed to do?
Yeah, I do believe that also here is a myth that eventually we need to correct. It is true that the complexity of what we are speaking about is very, very, very big, right? But the level of maturity of the ecosystem this day, so different type of organization that start to look at the problem and start even to work together to try to understand how to move forward is much more mature of what people may think. So a small organization can have many possibilities to look at what has been done so far, where the value is created, test by themselves with a very small investments, right? Ability to join work groups of a given field. It's relatively easy. We do have, within IBM, but it's even broader for finance, for healthcare, for optimization, for materials. So there are many entry points that everybody is interested to understand where the value is, what is coming and what is going to come in the future, and understand that. So it's relatively easy. Same, it's relatively easy to start to try understand where we are, and with a relatively small investment you can as he was saying do proof of concept that map your interests.
Thank you so much. In the interim, for those of us who are not physicists, who are not quantum and AI researchers, there is a book, Quantum and Pictures, by Bob Kirk and Stefano Coggioso. I mentioned it during our previous events, but I can tell you this is a great read, even for high school students. This is my go-to Christmas gift these days. So try to make a note of it and kind of spread the word around, because it's a really good start just to understand a thing or two about the quantum physics. Our next open mic participant, Alex Lee. Are you with us? Alex?
Yes.
Floor is yours.
Oh yeah, hi. Actually, Helen invited me this morning about seeing my recent post in LinkedIn. Actually, the post was about I recap report about yesterday there was a happened in the Washington DC that recently as you know that there was executive orders through the White House about the quantum future in the United States. So the Department of Energy actually host a summit to developing they call scientifically meaningful fault-tolerant quantum computing by year 2028. So it's a very similar timeline that they talk about in like QEra quantum computing hosted in the Amazon brackets. So so there was this is a motivation that there is the quantum computing is a national level, kind of like a concern and the matter. And then that in the sovereign quantum is in all of the advanced nation like Japan, South Korea, in China, and also European country like UK, Germany, France, everywhere, right? So they want to national level, the collaboration among the government laboratory and also private sectors, and so they want to make this plan as enable for by the time, right? So I just attend a webinar and then I just summarized what the status. And then in line of that, actually, I would like to what I'm doing. So I'm doing in two things. One is to at the current state of the quantum, it's a Niski state, it's still noisy, not the fault tolerance. So actually, even based at the current limitation, I apply the quantum computing for the many different types of industry, science, and enterprise problem to developing they call as you mentioned, AI powered. So I integrate, I'm a better expertise in agentic AI over the past 5 years. So integrating agentic AI as a intelligence layer to operating, orchestrating quantum computing plus any other traditional computing hybrid way like HPC and other GPU other type. And then we develop a platform. Actually, I affiliate on company. The name is Superq Quantum. They develop platform actually integrating this agentic AI plus all the hybrid computing resources to users that provide their problem in specific problem in any industry. For example, drug discovery, for financial, and any other, even the quantum security. And what I found, this is a reality because I experienced over the past 6 months, I tried to promote this to all different industry because I have 30 years in tech industry. So I nearly know any industries from semiconductor, telecom, and logistics, climate change, everything. So I based on this platform, I develop what kind of best practice. So means that where the bring the quantum advantage. So quantum advantage means two means. One is a problem itself is a quantum nature, like a molecular simulation is a quantum computing problem, like in drug discovery.
I hate to interrupt. This is an extremely interesting, and very insightful contribution. I think we should have another event, or we would welcome, your special.
Yeah. So my
contributor.
kind of commentary is that to the end user level, it's very difficult to make them persuade and discuss to adopt the quantum advantage. So in the like vendor level, very as you said, I focus on, for example, the 11 modalities. Up to now, I analyze all the like their performance and then migration. So there is a gap. So
Thank you.
I
Thank
like
you.
your
We really
kind
have
of
to move on
yeah.
because we
yeah.
will have to open the floor. There were a couple of questions. Pushkar Kumar, are you with us? You had a question. Tom, do you see open questions? Tom?
Yeah, there's one from Mike Camber. Adding to Alessandro's, or women. For a question for Alessandro and Yuval, the 2 or 3% who want quantum safe silently, what actually distinguishes them from operationally? Was it that they had a complete cryptonic inventory before the standalone standards landed, or is their architecture already crypto agile enough to rotate? Asking because the answer determines whether the other 97% should spend their first 12 months on mapping or re-architecting. This is from Mike Camber of Quantum Dynamics, LLC.
That's a complex question.
Yeah, it's a very complex question, but 2 words. I do believe that it's a mixture of everything you have said, but the most important things it's the perception and quantification of the risk that they had if they would not move. So that is why I was saying, once you perceive the risk as a very, very high risk and you can implement because you are more ready than others, you do it. Yeah, so both things together.
He also has another question. Let me see here. Adding to the answer for Hunan, the compute side he described as right, and there's a defensive half that is even more lightweight. Let's see, my thing keeps moving on me. So one, start the cryptographic inventory now. If you touch federal supply chains, Executive Order 14412 makes a crypto bill of material requirements anyway. Make crypto agility a procurement question on everything you buy from today. Can it rotate algorithms without re-engineering? And 3, literacy equals one named donor, not a team. Early mover advantage, describe compounds fast on the defensive side. Inventory and agility built now may make every future migration cheaper. So I guess he's just making a statement there. It looks like Ron has his hand raised. Ron, do you have a question?
1 minute.
Oh,
I'm sorry.
I said 1 minute because we're running out of time.
Yep. So keep it simple.
Oh,
Ron?
I actually had a question for Yuval, but it looks like he left. But I just want to make a comment about I always hear a lot about quantum computers not being ready for business, but there is a specific class, and it's basically the quantum annealers are solving really complex business optimization problems, and there's a number of companies that have these in production today. So quantum is definitely here. It's landed. It's true that quantum annealers aren't true. Don't utilize full-fledged qubits per the 𝐃𝐞𝐩𝐥𝐿 criteria, but they are really good at solving quadratic-based optimization problems, and there's all sorts of things in computer science that fall into that category. And I actually just yesterday saw an incredible demonstration of a company who is currently using a quantum annealer to assist their logistics software in helping a delivery company manage their truck fleet and their delivery points, and doing it in real time. And because the quantum computers, the quantum annealer can resolve any particular problem in a few seconds, they're able to actually deal with things that happen in real time, because as the guy was saying, the real world is a mess. So you can plan your routes, but you don't know what nature's going to throw at you. And it was really amazing. And they could just in a few clicks of the mouse, and they had an interactive map display for the logistics routing. It was really amazing. I just wanted to bring that to the table, because every time I come to something like this, I hear, oh, they're not ready. They're not ready. And the other thing I wanted to say about the post-quantum stuff is that you'll always hear people talking about Shor's algorithm. It's not the only algorithm that can break two-part keys. In fact, it has to do with gate-based machines using gates that are reversible. So it's essentially, if you have a large enough gate-based machine, you just program the algorithm that does the multiplication, and you just run it backwards. And there's a good chance that might be Shor's method to the punch and breaking encryption. So it's even more scary than you thought. So thank you.
Excellent insights. Thank you so much. As always, I really am sad to end our, I would say, amazing conversation. Thank you so much, our wonderful speakers, our Fireside Chat participants, for this really incredible discussion. Steve Suarez, Alessandro Curioni, Yuval Boger, thank you. Your remarks were brilliant. Tom, thank you always for your amazing help and support. And to every participant in our open mic and those who have questions, I am happy to share the news that Global Alliance on Sustainability and AI is now officially a 501c3 charitable organization, as acknowledged by the United States Department of Revenue, IRS. So if you would like to support us, we would be very, very grateful. We've been operating without any financial support since 2024, just on our volunteer effort. And now to amplify, we would appreciate your support. And when we post the video, please take a moment to like it, to share it, to amplify, because the quantum AI convergence is no longer future. It's already here. It's reshaping every part of our lives, from cures to cybersecurity to industry and exploration of space. Today, we had 96 companies registered with representatives from 27 countries, every continent except Antarctica and Oceania. This is the reach of this conversation. Move with agility and thrive in all of your aspirations. There is no limit. I'm Helen Teplitska, founder and president of Global Alliance on Sustainability and AI. And thank you from the bottom of our hearts for joining us. You shared your most valuable asset, after health, of course, your time. Thank you, and see you next time. Thanks. Bye.
Bye-bye.